Hey everybody, welcome to today's Kubernetes Clinic for open source tools that will change how you manage Kubernetes. Today's featured presenters are Robert Brennan, the Director of Open Source, and Andy Suderman, the Director of R&D and Technology at Fairwinds. As a reminder, today's session is going to be in listen-only mode. If you do have a question, please submit it in the Q&A tab in the lower right-hand corner of your screen. Robert and Andy, over to you.
Thanks, Dave. So as Dave said, I'm Robert Brennan. I'm Director of Open Source here at Fairwinds. I've been working in open source for about 6 years now, and about 2.5 of those at Fairwinds. Big fan of open source in general. I've been building software for about 10 to 12 years now, and I have to say, just the explosion of open source over that period has been really tremendous to see. It's made my job a lot easier and a lot more interesting. So I'm really happy to be here.
And I'm Andy. I'm the Director of R&D and Technology. That big wordy title just means I'm responsible for technology here, mostly regarding our managed service offering. I've been doing open source at Fairwinds for the last 3 years. I have been doing operations for about 10, and I've been working with Kubernetes for about 5 now. So I've been in the ecosystem for a little bit, and just super to reiterate what Robert said, I'm super excited about open source, and I really love the momentum it's had over the last few years, and the opportunity I've had here at Fairwinds to participate in it.
So just to tell you all a little bit about Fairwinds and how we work with Kubernetes. We've been working with Kubernetes for over 5 years now. So most of Kubernetes life, we've been a part of that ecosystem. We do a lot of hands-on services to help our customers basically build Kubernetes clusters, and then we'll manage those clusters going forward for them. But over the course of managing hundreds of clusters across dozens of clients, we really noticed a lot of the same issues coming up over and over again, and we started building a lot of software, most of it open source, to start addressing those problems. So you may have heard of projects like Polaris and Goldilocks, which we'll get into in a little bit. But those are Fairwinds projects to help address those concerns. And then after building a bunch of open source, we actually ended up building a commercial software platform called Fairwinds Insights to help round out the functionality of our open source with something that's a little bit more user-friendly, a little more plug and play through our SaaS at insights.fairwinds.com. So we have a quick polling question for those of you in the audience. We'd like to know if any of you have used our open source projects before. We've got Polaris, Goldilocks, Pluto, and Nova. And I think y'all can see we have a second polling question as well. What is the greatest opportunity that you have to improve your Kubernetes environment? Getting help with the basics, general best practice assessment, implementing the right security configuration, saving money, or improving your service reliability. Leave that up for a few more seconds so folks can answer. Sounds like the biggest response is Polaris, which is not a huge surprise. It's definitely our most popular project. So glad to hear folks are using that. We can move forward. Cool. So speaking of Polaris, one of the biggest problems that we've seen after managing, again, hundreds of clusters across dozens of clients, is that folks are using default security settings for their workloads, and often those default settings are not the most secure thing that you could be doing. It's easy to add some Kubernetes configuration that tightens down those defaults a little bit more to adhere to the principle of least privilege. And so to address this problem, we built Polaris. Polaris comes with 20 built-in checks to check not only security issues, but also reliability and efficiency issues. So it'll check for things like whether your container is allowed to run as root, whether the file system is read-only or writable. It'll check if you have liveness and readiness probes set for your workload, if you have CPU and memory requests in them, it's set. Really just a lot of best practices are encoded in Polaris, and it's a good way to just know that you've really looked at your workloads and made sure that everything you're doing adheres to those best practices. We also support custom checks in Polaris using a schema language called JSON schema. That's actually the same schema language that Kubernetes uses under the hood to validate anytime you kubectl apply something to make sure that that YAML actually matches the schema that Kubernetes expects. And what's great about Polaris is that it can run in 3 different modes. It can run as a dashboard, just showing you everything in your cluster and how it's doing against those best practices or against any custom checks you've written. You can also take one step left and run it as an admission controller, which I like to think of as like a bouncer for the cluster. Basically, anything somebody tries to kubectl apply or Helm install into your cluster that doesn't conform to your policies and those best practices, Polaris will reject that workload. And then you can also run it as a command line tool against your infrastructure as code. So you could say add Polaris to your GitHub repository or your CI/CD pipeline to make sure that any changes that are being made adhere to those best practices.
All right.
And I think Andy has a quick demo here. Yeah.
Yeah, I'll do a little bit of a demo of how the different ways you can use Polaris. All right, so here I have I'm connected to a Kubernetes cluster. I can run kubectl commands against it. Thank you, Robert, for using the correct pronunciation of kubectl. I appreciate it. And so typically we install Polaris with a Helm command. So I'm going to install it straight from the Fairwinds stable Helm repository into my cluster. Just going to put it in another namespace that I've called infra. I actually did this ahead of time just to make sure it was working, but I'll rerun that command so we can really quickly install that. It's fairly straightforward to get running in our cluster. The output will just show us how to access that. So I'm going to just port forward straight to the Polaris dashboard service. And then we can go back to our browser and we can go to the localhost port that we just port forwarded to. And we'll see a lot of information up front real quick, but a little bit of just description here. We've got, we give a score based on checks that are passing, checks that are failing. We list the number of passing checks. There's a cute little pie chart there. And then if we scroll down, we can see that we've broken these different checks into different categories. So we have efficiency checks, reliability checks, and security checks. And then we see all the different namespaces, the different workloads, and then the different checks that have run against those. So in the demo here, I'm going to focus on my application, because if you're an application developer, maybe you're more focused on, what are the issues that my application is having. So I have an application running in the demo namespace. I've filtered down to just that, and I can go down here and see that I have a deployment called basic demo. The pod spec seems to be okay, but the container specification has some issues. It looks like, I'm failing this privilege escalation check. I'm failing the image tag. So we could take a look at this. And the nice thing is you can click that little question mark next to the finding, and it'll take you straight to our documentation, which will describe what the check was, what the default level for it is, and what it really means. So there's some information there about how you can mitigate as well. So if we scroll down, I don't see there we go. Docker's latest tag is applied. Shouldn't use latest. That's what it's telling me about the image tag here. And then privilege escalation should not be allowed. Let's see. I haven't looked at this in a bit. but looks like we need to set security context.allow privilege escalation to false. So if I want, I can go in and start mitigating those things in my application. And again, it'll show me that for all the different namespaces. And I'm actually pretty happy here because I'm passing a lot of checks. So that's good to see. So that's the dashboard for Polaris. That's how you might use it in your cluster and view this dashboard. However, there's other ways to run Polaris. So I'm connected to my cluster still. I'm going to just run this directly against my cluster. So I'll just run the Polaris CLI, Polaris audit, and it looks like I got a score of 74 and I've got some JSON here, which is great if I want to like send that somewhere else, add it to another reporting tool, who knows what I can do with that. But really what I want is I want to be able to see this output and see the checks that were run. So I can run the Polaris audit -- format equals pretty. And now I've got, hey, here's all the checks. Here's the ones that passed. Here's the ones that are failing. And some nice little emojis to go with that so that I can see where the dangers are. And then there's actually another really nice flag I wanted to show here. If we look at the help, if you don't want to see all the successes and you want to see just your failures, you can say only show failed tests, and then it'll filter that down to things that were not a success, which kind of makes the output a little bit easier to read, in my opinion. The last way that we can run Polaris, you may want to run it against your infrastructure code or your deployment code and not just against your cluster itself. And so we have another functionality here where I'm in the Polaris, actually I'm not, but we can go there. And Polaris, and I'm in the Polaris repo. I can run a Polaris audit path test webhook cases. So just some test files that we have in here. I'm going to pass that format pretty flag again. I'm going to, for CI, I want to set an exit code. So now if my code doesn't pass a certain threshold in Polaris, I want to fail my CI. So I'm going to pass the set exit code below score 70, only show failed tests like we did before. So now I can run that against these test files and, oh, not format - pretty, format equals pretty. Dangers of a live demo. There we go. And we see that my code is failing tests and my audit score was 0. So that's not great. We can check the exit code on that. It exited 4. So now I know that my CI would have failed if I had run this code against run this CI check against my code. And I think that's all I have for Polaris. And I'm going to keep talking. I'm going to keep talking about the next project we have. Another problem that we ran into a lot when running clusters for our clients was that they wanted to set their resource requests and limits, because we told them to do that. We said you need to set resource requests and limits for all of your applications so that they run smoothly in your cluster. And they said, well, what should we set them to? And we said, is it not switching? Sorry about that. There we go. Thank you, Dave. So we said, we can make recommendations for you. And what we would do is we'd go into Datadog and we'd look at a dashboard and we'd look at historical usage. And it was just kind of this arcane bespoke process that we had for providing these recommendations to clients. And I said, there's got to be a better way. So I went looking for a recommendation engine. I stumbled across the Vertical Pod Autoscaler project, which you may know as Vertical Pod Autoscaling, but I use it for its recommendation engine. I really like the way that it does recommendations. We use Horizontal Pod Autoscaler, which doesn't play nicely with the Vertical Pod Autoscaler, but I can still utilize it for the recommendation engine. So this led to a project called Goldilocks. Goldilocks is a controller that runs in your Kubernetes cluster, and it can create a Vertical Pod Autoscaler object for any deployment in your cluster. And so it creates one that associates with the deployment, and then it sits there and runs in the background in recommendation mode, and it provides recommendations. And now that we have these, dozens or hundreds of vertical pod autoscaler objects, now we need to collate those results. So Goldilocks also has a dashboard that can go in and pull all the recommendations out of those vertical pod autoscaler objects and show them to you in that dashboard. It's because it uses the vertical pod autoscaler as the recommendation engine, it's a little bit limited in its capability. You can expand that by connecting the vertical pod autoscaler to Prometheus. So I'll go ahead and demo that next. All right, so like Polaris, we'll install Goldilocks with a Helm chart. I'm using another one of our tools called Reckoner, which we're not going to talk about today, but I'm just going to install Goldilocks. The key is I'm setting a value called vpa.enabled. And what this is going to do is it's going to install the vertical pod autoscaler control plane into your cluster via the vertical pod autoscaler chart that we maintain as well. So important thing to know is that in the Goldilocks namespace, we have the VPA recommender running, and that's the most important part here. The other thing that's required for Goldilocks to run is that the metric server is available. So we have the metric server running in the metrics namespace. We can get host level metrics, and so we know that metrics are available in the cluster. So the last thing you have to do once you've installed the chart is you have to label your namespaces for Goldilocks to look in them and to work in them. So here I have labeled every namespace in this cluster. I've said goldilocks.fairwinds.com/enabled. And so hopefully when I look at my dashboard, I'll have some results. So let's do another port forward. We're going to port forward to the Goldilocks dashboard service. And I'm going to port forward that on 8081. We'll go back to our browser and refresh this page, and we will see when we get to Goldilocks, we see a list of all of our namespaces. This may look fairly familiar from the Polaris demo because all the namespaces are the same. It's the exact same cluster. Again, I'm going to focus on my demo application. Go here, and I see we have a deployment. In that deployment is a container. If we had multiple containers, those would show up here. And we have two different sets of recommendations. So this is where I need to talk a little bit about quality of service. If you're not familiar with the concept, in Kubernetes, when you define the CPU request equal to the CPU limit or the memory request equal to the memory limit, you're defining what's called a guaranteed quality of service. So you see here, we have a definition of that straight from the documentation and a link back to the documentation as well. So we provide two different sets of recommendations. One of them is the guaranteed QoS. One of them is burstable. Burstable, what we do is we take the vertical pod autoscaler's recommendation for its lower limit and its upper limit, and we say you should have your requests and limits somewhere in between those. And so this is the current CPU request and CPU limit for this container, the current memory request, current memory limit. And if I were to take this recommendation, looks like I would turn that up to 15 and 51. Looks like it's been kind of floating between those two settings. This application is really small and lightweight, so the numbers are pretty small, and we may be hitting the minimums on the vertical pod autoscaler because it has a minimum setting of what it will potentially recommend. And then over here we have a recommendation of set guaranteed to 15, and then the memory request and memory limit to 105 megs. And then if we pop this box down here, we can see the code that we would want to copy directly into our specification for our container if we wanted to use that particular recommendation. If we want, also, we can look at all the namespaces at the same time. So here's that situation with multiple deployments, maybe somewhere we have multiple containers, but generally I just prefer to go by a single namespace. All right, and that's Goldilocks. I think I'm going to kick it over to Robert here.
Well, so the next issue we hit was specifically, it became a big problem for us when we were updating all of our clusters to Kubernetes 1.16. In 1.16, a lot of Kubernetes resources were removed that had been deprecated for a while, and a lot of our customers were still using those old deprecated resources, which prevented us from moving them up to 1.16. And so we built a project called Pluto to help detect in infrastructure as code or in deployed Helm charts any resources that are using old API versions that Kubernetes has either deprecated or removed. The Pluto basically works by looking at the API version of those resources and seeing, basically correlating that against a list of deprecated and removed API resources that we maintain. The reason that this is so necessary is that surprisingly, the Kubernetes API won't tell you if you're using a deprecated resource. So if you say, deploy the deprecated API version, and then you do a kubectl get or kubectl describe on that resource, it will report back the most recent non-deprecated version. It seems Kubernetes is kind of up converting those to the latest version. So it's hard to tell just through kubectl, what's actually inside your cluster. Through Helm configurations, we're able to detect that automatically, and through CI/CD, it's a lot easier because it's explicitly stated in the YAML. So Pluto can check both of those contexts to make sure that you're actively using the latest and greatest API versions rather than old and deprecated or removed ones. And that'll make it a lot easier to get up to newer versions of Kubernetes. Andy, did you have a demo for Pluto as well?
I do have a demo. Just a quick note on Pluto. It may become obsolete in the nearest future. Kubernetes has finally introduced ways of warning you about deprecated API versions, but I do believe Pluto is still a very nice way to kind of summarize those all in one place, run them in CI/CD and things like that. So here I have, again, the exact same cluster. So I have my Pluto binary installed. There's an ASCF plugin for it if you're curious. And so I'm going to do in-cluster detection. So I'm going to do a Pluto detect Helm. And it's going to go and inspect all of the releases in my cluster, grab those manifests, and then scan them for deprecated API versions. So we see here, I have an ingress called basic demo from my demo installation that is using the API version extensions v1 beta 1. That API version has been deprecated but not removed in 1.16, but because that's the default that we use. But really what I want to know, because I'm well past 1.16 now, I'm looking to go to 1.20 because I'm currently in a 1.19 cluster. So I'm going to target the Kate's version v1.20. And we see here that it still hasn't been removed. So I can still deploy the object, but it is still deprecated. And the other thing I want to know is, where did this come from? Because I see that there's an ingress object, but I don't actually know where it came from right now. So I'm going to pass the -o wide flag and get a little bit more information here. That's great. We can see that it is in the demo namespace, which I already knew, but now we also see it was deprecated in v1.14, and it's going to be removed in 1.22. So I have a little bit of time to get that fixed, but I should probably get on that. So now I know that this chart has a deprecated version in it. And if I do a Helm ls over there, I see that it's, there's the chart version. It's on 0.2.2. But now I'm curious, maybe they have a more recent version of that doesn't have the deprecated version in it. So I'm going to do a Helm template on this comes from the Fairwinds incubator repository /basic demo chart. And so I'm going to template that, and I'm going to pipe that through to Pluto, and I'm going to run a detect on that. And let's just see, hey, look, there's no deprecated API versions in that chart version. So maybe that's what I should upgrade to, is whatever the latest version of that is. I think if we pass -li, we won't get any more information. I just want to check here. And so that's the second way to run it. You can do a Helm template, or you can just pass arbitrary things into that standard in dash replacement. And then the last thing that we might want to do is we want to do a CI check, kind of like we did with Polaris. We want to check our files before we deploy them to see if there's any deprecations in them. So I'm going to use some files that we have in the Pluto repository to demonstrate this. So I'm going to do a Pluto detect files. Pluto detect files. And then I'm going to target versions 1.20 again. And I'm going to do an O-wide again, just so I get a little bit more information. There we go. Looks like there's several things in here, several deployments of the old extensions v1 beta version. So I should definitely not be deploying anything in this folder to my 1.20 cluster because it just flat out won't work. That API version has been completely removed. So that's Pluto, pretty straightforward. The other thing to note here is that that exit code has been set, not exit, but the exit code has been set to something non-zero so that it will fail in CI if I want to run that check that way. All right. Robert, you want to talk about the fourth problem that we had running all these clusters?
Yeah, so the last problem is basically just managing Helm charts across all these clusters. So we, like I said, we manage a lot of different clusters. And we basically need to make sure that all the add-ons that we're installing into these clusters, things like Nginx Ingress, Cert Manager, all these charts, we need to be making sure they stay up to date to make sure that any security issues get addressed, new features get pulled in, bug fixes get pulled in, things like that. And it's hard to keep up to date. There's no standard way of subscribing to new Helm chart releases. So we built Nova as a way to really cross-check, what you've got installed in your cluster versus what has been published out in the wild. Nova can basically look at repository metadata to see what's the latest version, and it'll look inside your cluster to see what's the version you have installed. And if there's a mismatch there, Nova can bubble that up and say, hey, you can install this new version. And a great feature of Nova as well is that you don't have to always point it to the latest version. So like internally, we have a set of standards where we say, this is the version of Nginx Ingress we want running, this is the version of Cert Manager we want running, et cetera. So that we don't always have to be at the bleeding edge, which can sometimes be a little bit dangerous. Instead, we can say, here are the versions we want. And then we use Nova to actually do two things. One is we'll get alerted anytime a new version comes out that doesn't match our list of desired versions. And two, anytime we have a cluster that has something installed that doesn't match our list of desired versions, we'll get an alert for that as well. So Nova's been super useful for us just in terms of staying up to date and keeping all of our clusters consistent across that entire fleet.
Definitely. All right. So just a quick demonstration of how Nova works. Again, the exact same cluster that I'm connected to. So we can run Nova find using the Nova CLI. That's going to go look at all those releases like Robert said, and it's going to go try and find those in the upstream Helm chart repositories and figure out what the latest version is and tell us if they're old or not. So the one I want to point out here is that demo app that I was just talking about. We know that there was an updated version of it that didn't have upgraded versions. And we see here, hey, that basic demo chart has a much newer version. So maybe I should be using that. We can get a little bit more information if we pass the wide flag here. So that's a nice, easy, quick check, easy way to do that. The other functionality that we use most often, like Robert mentioned, is the fact that we don't necessarily want to be on the latest cutting edge chart. Like we may want to have a process by which we vet those charts and we test them and we test the upgrade process. So we want to maintain a list of sanctioned charts basically in their versions. So this is where the Nova config file comes in. You can actually generate a config file with the Nova CLI, Nova help. So there is a generate config command that you can use. So you just specify where you want it to put it with the -- config flag and run generate config, and it'll spit out the default config file. I've already put one in here, so I'm not going to do that right now. But see, I have specified some extra charts here. So if you want to put in extra repositories that you want to be scanning against, if you have your own in-house chart repository, or you have a bunch of different ones that you use. In addition, I have specified that I'm using Helm version 3, because if you're not using Helm version 3, then you really should upgrade. And the real important part is the desired version. So I've pinned that basic demo version, that basic demo chart, back to 0.4.1 here. And then for another example, I've just put in a version of the Kubernetes stack. So we can run nova find -- config and pass our nova config file that we were just looking at. And in theory, we should see, there we go, that basic demo chart. It's still out of date because we're on 0.2.2, but now it's saying the version that I want to be on is 0.4.1. Same with Kubernetes stack. It's now no longer out of date because it matches the version that I put in that file. So this is a really handy way to keep a sanctioned list of versions and charts that you want to have in your cluster. That's all I have for the demo. Go back to the slides here.
Thanks for all those demos, Andy. That's always a lot more fun to see things actually like working live rather than just people talking at you. So appreciate all that. So at Fairwinds, obviously we have a huge commitment to open source. We've shown you 4 projects here, but we have a bunch of other projects that we're working on. Here's a list of our official and incubator projects on the deployment side of things. We have, in addition to Pluto and Nova, which you all heard about today, we have Rocket Scripts, which is sets up a bunch of patterns for continuous deployment, basically helping you build Docker files, run Helm installs, and it supports a lot of great best practices like encrypting your secrets and storing them as infrastructure as code, being able to associate a particular Docker image with a particular commit in your Git repository, things like that. It's a really powerful project. We use it a lot internally and with our clients. Reckoner is a great project for managing Helm installations. You saw Andy use it a little bit earlier in the demos today. It allows you to basically declaratively install and manage several different Helm charts within the same configuration file. So if you've got a set of add-ons like Nginx Ingress and Cert Manager and whatever else that you're installing across all your clusters, it can be helpful to manage all those in a single place, and Reckoner can help with that. Once you've already got a cluster running with your applications inside of it, we have a handful of open source projects that can help you manage those going forward. RBAC Manager is a great tool for managing RBAC easily enough. RBAC in Kubernetes is a really difficult and complex topic. It's hard to get right, and RBAC Manager simplifies that interface to make it a little easier to see everything in one place and understand actually what's going on inside your cluster, who has access to what. We also have Astro, which is a Datadog integration. Astro allows you to dynamically create Datadog monitors in response to certain objects getting added to your cluster, et cetera. It's a great way to make sure that everything that's running in your cluster is being monitored by Datadog. If you're keeping persistent state in your cluster at all, Gemini is a great tool for automating backups of that persistent state using the Kubernetes native concept of volume snapshots. It allows you to set a schedule and basically store those snapshots inside your cloud provider. And then Sapphire is a great tool for eliminating basically the potential for a Docker registry outage to take down your application. So if say Docker Hub goes down, you can set up Quay as a backup, and then your cluster can pull from Quay instead of Docker Hub in the event that Docker Hub does go down. We've experienced a lot of pain with Quay in particular going down at Fairwinds, and having Sapphire there to fall back to, fallback images has been a big help. And then on the optimized side, we have, as we mentioned before, both Polaris and Goldilocks are great tools to help you make sure that you're doing everything according to best practices and that you're setting those memory and CPU requests and limits to appropriate levels. So, we've talked a bunch about open source today, and open source is great, and, because it's free, because it's developed out in the open. You can contribute to it where it's lacking, but a lot of times, deploying open source can be difficult. Doing it at scale can be even harder. And so, as I mentioned before, we built Fairwinds Insights, our commercial software platform, as a way to ease a lot of that pain. So Fairwinds Insights comes with a single installer that will take a lot of our open source, the 4 projects that we talked about today, as well as some third-party open source from companies like Aqua Security, with tools like Trivy and KubeHunter and KubeBench. It'll install all that in your cluster and collect all the results in one place. So you can see it through a single pane of glass, basically. Insights normalizes all the results coming from each of those different tools and puts them, into a single view, so you can see, your NOAA findings alongside your Polaris findings, alongside Trivy findings, et cetera. And it also makes it really easy to do that across many different clusters. If you were to, say, try and run Polaris against, an entire fleet of clusters, you'd basically have, a dozen, 2 dozen different dashboards that you need to go to, one for each cluster, to see exactly what's going on. Polaris can aggregate all that into one place so that you can see across all your clusters, which of the clusters are in the best shape, which need the most work, what are the findings that are consistent across all your clusters, that sort of thing. And you can also track your findings over time, so you can see how your Polaris score has been going up or down, depending on what practices you've put in place. Again, this is just a little graphic showing how all this stuff fits into Fairwinds Insights. Basically, Insights is the common platform, and then all these different tools plug in. So you see Polaris going in to check those Kube security best practices, Goldilocks plugging in to check that your memory and CPU requests and limits are set properly, Trivy going in to identify any container images that are running known CVEs. Each of these kind of plugs and plays into Fairwinds Insights. So if there were a new open source tool that got launched, next week, we could basically write a plugin for Fairwinds Insights to get all that data into Insights. So it's really a platform for open source Kubernetes auditing. So we asked the second polling question earlier. What is the greatest opportunity that you have to improve your Kubernetes environment? And it looks like the top answer, if I can pull it up here, is getting help with the basics. So it sounds like folks are really just trying to get up and running with Kubernetes for the first time, or maybe have a cluster or 2 up and running and are trying to make sure they're doing things right. So good to know. Thank you all for answering that polling question. I do want to give a quick plug for our white paper. It's called the top 5 Kubernetes security mistakes that you're probably making. This is a great resource for anybody who is new to Kubernetes or new to Kubernetes security, or who's just concerned about the security of their cluster and their workloads running in that cluster, and making sure that they're paring things down and really hardening that cluster for production. I think we'll share a link to this white paper after the webinar. You all should get an email with it. Well, and I think we have some Q&A. If there are any questions from the audience, feel free to drop them in the Zoom chat.
Yep, so I have a couple that are already queued up, Robert. The first one I think is from when you did the first demo, and the person's asking if you can share the 20 built-in checks.
Yeah, so I won't bore you all by listing off all 20 checks right now, but if you go to polaris.docs.fairwinds.com, you can see the list of checks there. They are split into 3 categories: security, efficiency, and reliability. So you can peruse there and see what we've got. You can also see, if you go to the GitHub repo, which is github.com/fairwindsops/Polaris, there's a checks folder that actually has the list of all 20 check names as the file names. And then if you click into the file, you can actually see the schema that it's enforcing. So, for liveness probe set, you can see the JSON schema there to actually drill in and make sure that liveness probe field is set for each workload.
I went ahead and dropped those links into the chat for everybody.
Nice.
And as Robert mentioned, after the event, we will send out a link to the white paper so everybody will have access to that. I have another question here. The person's asking if you can describe in a little bit of detail on the VPA within K8's primitives, what objects get auto-scaled?
I could talk about it briefly. We don't actually use the auto-scaling functionality of the vertical pod autoscaler because it doesn't work alongside the horizontal pod autoscaler, which is what we typically use. The vertical pod autoscaler is actually written in such a way that it can work with any pod controller and scale the requests and limits on the pods underneath that controller. So you could use it with deployments, daemon sets, in theory, stateful sets, although I can't guarantee that. Currently, Goldilocks only supports deployments. We do have an open issue to work on that and to expand the functionality out to be in line more with what VPA is capable of.
Okay, we've got looks like one or two more. The next one is what's the difference between using an open source container scanning solution like Trevi versus a commercial product like Sneak?
It's a great question. The big thing I would say is that if you're going to use the open source, you're probably going to be detecting the same vulnerabilities, right? It's all the lists of CVEs out there are open. So hypothetically, Sneak and Trivi will be able to do the same job there. What's helpful about a platform like Fairwinds Insights or Sneak is that it can simplify the way you apply that open source or the way you apply container scanning, right? So Trivi by itself is just a command line tool that you pass it the name of a Docker image and it'll download that Docker image and check it and spit out a bunch of results to your command line. If you want to say get those results sent to you in Slack, or you want to track those results over time, or you want to automatically scan every repository in your GitHub organization, or you want to scan every image in your Kubernetes cluster, you're going to have to do a lot of plumbing, right? You're going to have to write a lot of scripting to get it plumbed into your environment. And a tool like Fairwinds Insights, for example, it uses Trivi under the hood, but there's a lot of plumbing involved to be able to grab a list of every image in your Kubernetes cluster and do rolling scans so that we're constantly checking those images, making sure they get rechecked over time, making sure that new images that come in get checked. We're also able to do those scans consistently across CI/CD, where it's scanning your infrastructure as code, those Docker files as they're getting built. Before any changes to them get merged, we can scan them, and then we can also scan the live running cluster so that even if all the checks passed in CI/CD and that container image made it into your cluster, if a new CVE gets announced, we'll be continuously scanning that image so that the new announcement will catch it and bubble it up and can let you know. So I would say the open source is often good enough for small environments, or if you don't have really hard requirements about where and when you're doing the scanning. It's a great way to just test out container scanning and see what it's all about. But you're probably going to want a SaaS or some kind of commercial provider to do a lot of that a lot of that plumbing to get the information into the right place and make sure you're doing scanning in all the right places.
Okay, looks like I've got one or two more. Next one is what non-Fairwinds open source tool do you recommend for auditing Kubernetes clusters?
Some good ones are, so we mentioned Trivi. I think that's a great one for doing container scanning. We also have used KubeBench. If you're interested in the sys benchmark, is a good tool to just tell you how good your Kubernetes installation is against the sys benchmark. That's checking more at the cluster level type stuff. KubeHunter is also a great tool that does a lot of hunting around in the cluster for basically it does a network sniffing within the cluster to see what kind of information it might be able to get access to. So if you had a pod that got compromised, you can see what an attacker would be able to see from that pod. Andy, any other open source tools out there in the wild that you would recommend?
Specifically for Kubernetes, I can't think of any off the top of my head that you haven't mentioned. Yeah.
Cool. All right, and we have one more question here. A lot of the tools audit infrastructure as code. Is there a way for me to put them all into my CI/CD pipeline?
Yes. So as open source, you'll probably need to download each of these independently and things like that. For the ones that we've discussed today, you can use Fairwinds Insights. It will, we have basically a single installer for your CI/CD pipeline. It will grab all those open source projects, run each of them, and then upload the results to the Insights UI. There's a nice tight GitHub integration as well, so you'll get a nice, readable, Fairwinds Insights found, 2 new problems with this PR. You need to fix those before you're able to merge, that kind of thing. So Insights does a good job of packaging up a lot of open source and making it easy to deploy, whether it's in CI/CD or in a live cluster.
Okay, I guess at this time I don't see any further questions. So I guess if there aren't any further comments, as I mentioned, we'll make sure we get a link to everybody with the white paper. And I'd like to thank Robert and Andy for a great job on today's webinar.
Thanks, Dave.
That'll conclude today's session.
Thank you.